The ethics case study that we were given to assess as a guild was the Challenger shuttle disaster. There are many ethical issues and challenges that ultimately decided the shuttle's fate, from designing the shuttle to constructing and operating the shuttle. This event occurred on an unusually cold day at the Kennedy Space Center in Florida on January 28, 1986. At 11:39 a.m., the Challenger shuttle unexpectedly exploded 73 seconds into the flight and unfortunately killed 5 NASA astronauts and 2 payload specialists. This explosion was caused by a faulty design of an O-ring seal in the right solid-fuel rocket booster. The cold weather combined with this fault allowed hot gases to escape the booster, which also allowed the flames emitted from the rocket boosters to seep into the failed seal, igniting the rest of the fuel tank. The actor that our guild chose was a group of design engineers that are designing the structure and construction of the space shuttle.
Here are some ethical issues and challenges surrounding this case study. First, Thiokol, the company who made the O-rings, was aware of the joint seal problems, and there have been constant reports of this faulty design from 1977. Although the recommendation was to redesign their product, Thiokol instead tried to fix the problem but eventually failed to do so. Second, when the temperature issue emerged, it didn't pass up to the top positions within the company, so this wasn't considered as a significant factor of the performance of O-rings. There were not enough tests performed to prove that O-rings wouldn't work at lower temperatures, leading the decision makers to approve documents that support the launch of a Challenger shuttle. Some ethical responsibilities and dilemma facing engineers here are as follows. One is to comply to the company's procedure and work accordingly. This keeps the engineers from redesigning O-rings. Two is to finish the project on time, which pressures them to accept the faulty design. Three is to put health and safety first, that risks their professions because they have to go against the employer and the client.
An alternative option for the engineers was to create a better O-ring design, ensuring that there is no seal or performance problem to begin with. The engineers could have communicated among themselves much better to avoid the faulty design and meet the deadline. Another point is when the issue wasn't taken seriously by the organization, the engineers should have stressed the severity of the problem created by the cold temperature. They could have done the tests and collected data beforehand to prove that the design had errors. This would have resulted in the organization realizing the problem and taking action. Another option that would have saved the passengers was to consider the crew safety and build an escape system. These would be much more ethical decisions as the engineering code of ethics would be followed and no innocent life would face unnecessary harm.
Assessing the alternatives using a deontological approach, the alternative options are ethical because they correspond to the following duties of engineers. Number 1, disclose any concerns to the employer. Better communication between NASA and Thiokol engineers should have been prioritized. It is an engineer's duty to ensure the people's safety is always kept as a priority. Therefore, any concerns should be let known to the employer, managers, and the crew as soon as possible, and should be assessed in order to identify solutions. Number 2, acknowledge errors and fix them. It is a crucial duty to understand that the slightest of errors can be fatal in such important situations. The physical design and construction should be reviewed by all members of the crew involved in the design of the shuttle. All types of environmental situations should also be considered so the construction is of a more adaptive build. This would aid in ensuring all areas of the construction are done as precisely and safely as possible. Number 3, regard safety as paramount. Due to the high amount of pressure on the engineers designing the Challenger, many problematic aspects were ignored. To avoid this problem, plenty of time should be given to the engineers in charge of the design, giving allowance of time to create backups and safely handle any detected problems if that needs to be done. After possible errors and concerns have been disclosed and adjustments have been made, regular safety procedures should be followed to maintain operational safety.
The preferred ethical option that we as a guild recommend is to regard safety as paramount. The main issue that caused the fuel leak was negligence and a lack of forethought. Basic safety protocols that should have been followed were neglected due to the deadline that the engineers were trying to meet. Any deadline should come second when human lives are on the line. We also believe that if engineers spent more time on the safety of the crew, measures could have been put in place such as early warning systems or fail-safes to notify the crew if there were any problems before launch. Because they were rushed, an issue with the O-rings were neglected to meet the deadline, and an easily avoidable incident occurred. Safety should come first, especially when human lives are on the line.